Hello students, here we are going to see the duty ratio control for our DC-DC converters. We know that the output voltage, the average output voltage for DC-DC converters can be regulated by changing the value of duty ratio, right? That is D. So which is given by T on by T on T on plus T off. Okay, so we can change the value of D here, duty cycle, by changing turn on time, or we can change the D value by changing turn off time. Okay, we can either change the turn on time or turn off time to change the value of D, so that the average output voltage of the converter can be changed. Okay, so we have two converters here, so that is buck or step down converter, step down or buck converter, which has the expression for output voltage V naught equal to D times supply voltage, whereas we have expression for average output voltage of step up chopper or boost converter, that is V naught equal to Vs by 1 minus D here. Okay, so we have these two expressions for step down as well as step up transformer converters. Okay, so if we can change the value of D here, because supply voltage will be constant, if we somehow change the value of this D here, we can change the value of output voltage, average output voltage of the converter. Okay, so to change this value of duty ratio, we have basically two methods. Okay, one is constant time period method, and the second one is variable frequency method. Okay, so these are the two basic methods using which we can change the value of duty ratio. Okay, so this D is ultimate duty ratio, or it can also be called as duty cycle. Okay, so some of the textbooks will indicate this D as alpha or K. Okay, all are same, T on by total time period. Okay, so let us see how can we change the value of D using constant time period method. Okay, okay, so here we are going to see the first method to change the value of D here, that is constant time period method. This method is also called as constant frequency method, because if we can keep the frequency, time period constant, we can keep the frequency constant. Okay, constant time period or constant frequency, or this can also be called as pulse width modulation technique, famously called as PWM. Okay, so let us see. So here we are going to change the value of D here. D can be changed by changing either T on time period or T off time period, right? So let us consider the waveform for, let us take the time period waveforms here. Okay, so that means I am going to give you the pulses here So these are the periods. Let us take these are the periods here. Okay, so we are trying to find out the way to change the value of d here. Okay, so if I keep the value of d constant, if I keep the turn on value constant, that means if I keep, so let us see, this is the turn on time. Okay, and I am going to leave the 3 periods left for turn off period, and this will be our turn on time again. Okay, so this is our turn off time. Okay, and again this is our turn on time. So if you want to find the duty ratio for this cycle here, so what is a full cycle here? The full cycle is starting from 0 here, and it is, we consider that a cycle, the time period is the period for a cycle which repeats after some time period, right? So after this t time period, this cycle will repeat. Okay, so this wave here, it will repeat, and it will repeat after the same time period. Okay, so this is our time period, okay, in which the cycle repeats. So this is the time period. Okay, after this time period, the cycle will repeat, right? So this is nothing but time period. This is how we are going to find the time period of the given waveform. Okay, so the cycle will be repeated after the specific time period, right? Now we have t as total time period, which is equal to sum of t on and t off. Okay, now if we can find the duty ratio for this waveform here, that is t on is, if we divide this time period into 4 parts here, t on is nothing but t by 4, right, where t off is, total time period is t here. So duty ratio for this waveform is, we can cancel out this t and t, the d value can be written as 1 by 4 here. Okay, so by keeping the t on for 1 period and keeping the t off for 3 periods, we are going to get the value of duty ratio as 1 by 4. Okay, now let us change this turn on period to 3 periods. Okay, 3 slots here. Okay, here we have
1 second. Okay, so this will be 2 seconds, 3 seconds, 4 seconds. Okay, we have total time period as 4 seconds. What is 4 seconds? Okay, let us assume the example. Okay, so t on for our this waveform is 1, so total time period is 4, so we can get the duty ratio t on by total t, which is equal to 1 by 4. Okay, so this is how we are going to get the value of duty ratio by changing the t turn on period 3 seconds and turn off period to 1 second. Okay, we can change the, so I am going to change the turn on period to 3 seconds to 1 second. Okay, so here we are going to change the t on to 3 seconds here. Okay, and the total time period will be 4 only. So this is 1, 2, 3. So we are going to keep the t on for 3 seconds. Okay, so this is t on period. The switch is on for 3 seconds here, and it is off for 1 second. So this is t off. Okay, and again the same cycle will repeat after our time period t. Okay, so what is the time period here? The time period is t on plus t off here. So this is our time period, total time period. Okay, now if we want to find the duty ratio for this cycle here, so here this is your turn off period of the switch. Okay, we are talking about the turn on and turn off periods of our switches in our buck and boost converter. Okay, here what is the duty ratio we can find? That is t on by total time period. So this is total time period here, t on plus t off. Sorry, this is t off. So here this is the turn off period, right? This is turn off period. Okay. Again this cycle will repeat. Okay, so for next 3 seconds. Okay, so this will be your turn on period. Now we are going to find the duty ratio for this cycle here, that is t on is 3 seconds, that is 3 t on is 3 seconds here.
where time period is 4 seconds. So we can find the duty ratio for this turn on period is 3 by 4. Okay, so earlier we had the duty ratio for our T on for 1 second is D equal to 1 by 4, where the turn on period is 3 seconds. Now the duty ratio is changed to 3 by 4. So this is how we are going to change the value of duty ratio. Okay, so here D1 was 1 by 4, whereas D2 was 3 by 4. Okay, so if we want to find the output voltage for a buck converter with supply voltage as 20 volts, okay, so what will be the output voltage for this D1 here? So that will be 1 by 4. I am talking about buck converter, that is D into Vs here. Okay, so 1 by 4 into Vs is 20, that will be 5 volts. V0 is 5 volts. So coming to this duty ratio, that is 3 by 4 into 20, that will be 4 5s are 3 5s are 15. So the output voltage is 15 volts. Okay, so for D equal to 1 by 4, the output voltage is 5 volts. For D equal to 3 by 4, the output voltage is 15 volts. Okay, so this is how we can change the output voltage of a converter by changing the duty ratio of the switch. Okay, so I hope you understand this. Okay, now we are going to see the second method to change the output voltage of the converter by changing the frequency. Okay, so that is nothing but variable frequency method. Second method is variable frequency method. So variable frequency is nothing but variable time period. Time period can also be variable. Variable time period method. Okay, so we know that frequency equal to 1 by t. Okay, if we can change the time period, we can change the frequency here. Okay, so how can we change the time period here? Okay, so let us take a graph for this. Okay, so here what I am going to do is I am going to change the turn on and turn off periods here. Okay, so I am going to keep the turn on constant and turn off variable first. Okay, so first I am going to keep T on constant and T off variable. Okay, that means, so let us consider the time periods here, time slots I can say. So these are the time slots. Okay, so let us take T on equal to 1 second, it is constant. Okay, so that will be so this is T on, this is second, sorry, so I am going to keep 3 slots open for T off. Okay, and again I am going to keep the turn on period. This is turn on period. Okay, so if you observe here, this is turn on period T on, whereas this is turn off period. Right, so what is the time period here? Time period equal to Tn plus T off. So for this waveform, the time period is 4 seconds. Let us take each slot is 1 second. Okay, so the time period is 4 seconds now. Now we can find the duty ratio, that is T on by T, which equal to T on is 1 second, total time period is 4 seconds. Okay, so this is what happened for this time period. Now I am going to change the turn off period here. Okay, I am going to change the turn off period so that the time period will be changed. I am going to draw the graph for so let me take the time slots. Okay, here I am going to change the turn off period now. Okay, so turn on is constant, okay, 1 second, but I am keeping the turn off also as 1 second. Okay, so that means here you can see the turn on is constant. Earlier the turn off was 3 seconds, but now I have reduced the turn off to 1 second. Okay, so here turn on is 1 second, turn off is also 1 second. Then what is the time period here? Here the cycle is repeating after every 2 cycles, right? So this is the cycle here. After this 1 cycle, after this is second cycle, after this is third cycle. That means cycle is repeating after every 2 seconds here. So that means time period is reduced. Time period is 2 seconds now. So we can find the duty ratio, that is T equal to T on by total time period. That is T on is 1 second here and total time period is 2. So the duty ratio here it is 1 by 2. Earlier it was 1 by 4. Now it is 1 by 2. You can see the difference. T on is kept constant, but T off is varied. Okay. So by changing the off time period of the switch, we can change the duty ratio here. Okay. So as we are changing the time period, okay, time period is changing. So what is the frequency? That is 1 by f, or f equal to 1 by t. So if t is changed, f will be changed. That is why it is called variable frequency method. Okay. As time period of the switching pulses is changed, the frequency, that what is the frequency called? Chopping frequency. The chopping frequency also changes. Okay, so that is why it is called variable frequency method. Okay, that is why it is called variable frequency method. Variable frequency method. Okay, so you can keep the turn off constant and you can change the turn on. Okay, so that is also possible. Okay, you can keep the turn off period constant. So let us keep turn off period constant and let us see what will be the effect of duty ratio if we change the turn on period. Okay, so here I am going to keep the turn off period constant. Okay, and then I am going to change the turn on period. Okay, so for this method I am going to keep turn on as 3 1 second. Turn off is fixed, right? Turn off is 1 second. Okay, I am going to change the turn on here. Okay, so let us take the time period for 4 cycle here, 4 slots. Okay, so here turn on is, let us take 3 time periods, 3 slots. Okay, that is 3 seconds. So this is our turn on period. Okay, so the cycle will be repeated after every 4 seconds. Okay, so what is the turn off time here? So this is the turn off period. Okay, so turn on period is 3 seconds here. Total time period is 4 seconds. So if you want to find the duty ratio, that is T on by total time period T is equal to T on is 3 seconds here. Total time period is 4 seconds. So the duty ratio for this waveform is 3 by 4. Okay. Now I am going to change the turn on to 2 seconds. Okay, so turn on will be fixed, turn off will be fixed. Okay, turn off will be 1 second only, but I am going to change the turn on to 2 seconds. Okay, so let us take the time slots here. Okay, so this is time period t, time t. So I am going to keep that turn on to 2 seconds, but turn off is fixed, which is 1 second. Okay, so turn on is 2 seconds now. Earlier it was 3 seconds, now it is 2 seconds. So this is 2 seconds. Okay, turn on is for 2 seconds. Now this is the turn on period, so this will be turn off period. So what is the total time period here? That is turn on plus turn off. Here the total time period is 3 seconds. So if you want to find the duty ratio, that is T on by total time period. So T on is 2 seconds and total time period is 3 seconds. Here you can see the duty ratio is changed to 2 by 3. I have kept the turn off period constant, but I changed the turn on period. Okay, the duty ratio is changed from 3 by 4 to 2 by 3. Okay, so if you want to change the value of output voltage of the converter, okay, we are going to change the value of T on or T off. Okay, so that we can change the value of output voltage. Okay, so that means if you observe here, the time periods were different. So the time period for first method is different for time period for second method. Okay, this is, as time period is varying, we can say that the frequency is also being varied. That's why it is called as variable frequency control. Okay, so this is about duty ratio control. I hope you understand. Thank you.